Good afternoon, everyone. Good evening or good morning, wherever you are joining us from around the world for session 8, the final session of the 2022 Oxford GeoHeritage Virtual Conference. You are most welcome joining us today. Thank you for your time. Thank you for all the engagement this week at the many sessions, for the talks, the flash talks, the posters, and indeed our wonderful poster presenters. I'm sure will be happy to continue to take your session questions over the next few hours in the Discord server. A quick reminder, we've got 2 brilliant talks coming up, and then we are going to see our final keynote speaker of this conference. If you have any questions for any of our speakers, you can either put them in the comments on YouTube or on Facebook, or indeed, please go onto the Discord server and you can put questions into the Talks and Flash Talks questions section of the Discord server as well. But without further ado, we will go over to Nathan Fox. Nathan, how are you today?
Jack, how are you?
Wonderful. Thank you so much for joining us. We're going to hear from Nathan, who's going to tell us about geodiversity and cultural ecosystem services, perspectives gained through social media analysis. Nathan, the floor is yours.
Thank you for the lovely introduction, Jack, and thank you for everyone who's been a part of putting this wonderful conference together. For those who don't know me, I'm Dr. Nathan Fox, a postdoc at the University of Michigan School for Environment and Sustainability. And today I'm going to be talking to you about how we can use social media analysis to assess the role of geodiversity in providing cultural ecosystem services. This presentation is going to kind of be a whistle-stop tour of all of the work I've done during my PhD, as well as the work I'm currently undertaking during my postdoc. So firstly, just as an introduction, I think when we talk about geodiversity, we all probably have a picture in our head that's very slightly different from someone else. And though the definition put forward by Murray Gray is the most commonly used, geodiversity is still used to describe a different combination of the abarctic environment. And this is something that I've definitely picked up on and has been reflected through quite a lot of the talks and posters during this meeting. When I started my PhD, I therefore created this descriptive framework that allowed me to better and clearer communicate the definition of geodiversity that I wanted to use. Here, I'm going to refer to geodiversity as the full range of abarctic features and processes, which is represented by the center of this framework. So for those of you that aren't familiar with cultural ecosystem services, in general, these are the non-material benefits we receive from nature. And these include things like aesthetic views, sense of place, spirituality, and even recreation. As benefits from these cultural ecosystem services are often unique to individuals, it's therefore difficult to assess or measure their value. And when I talk about value, it doesn't necessarily mean an economic value. Traditional methods of assessing cultural ecosystem services therefore tend to be things like stated preference social surveys or using travel costs as an estimate for giving a proxy value to a place's economic value. These data sets are often difficult to obtain over large scales and have other associated challenges. Here, social media offers a unique opportunity to study cultural ecosystem services. Websites such as Flickr, Twitter, and Instagram have all been used to assess how people interact with nature, including looking at aesthetic views and recreational activities. We're going to discuss a little bit further how we can use these data sets when I come to some case studies. Most often, these data sets are free to gather and can be retrieved in a relatively short amount of time, overcoming the issues associated with traditional data sets. As a quick interjection, today much of my talk will be focused on the website Flickr. Not everyone here may be a user of Flickr, so I just wanted to show a screenshot so everyone can imagine the data in the same way as I'm discussing. Looking at this map, the pink points are photographs that have been taken and uploaded to Flickr. Now these images are georeferenced, so we know exactly where the image was taken. You can see down in that white bar at the bottom, these are just a selection of the images that are the pink points. You can zoom into the map, you can query the map for words, such as geodiversity, and any image with the word geodiversity would then therefore be highlighted. These images are often accompanied by a text, title, description, and tags. There may also be a large comment section where people are discussing the image, and there's also going to be information about what type of camera was used to take this photograph. However, there are some big challenges to using these data sets. And the biggest one is that there's a relatively high skill level required to access these data sets. Coding methods required to get these data sets require knowledge of web APIs and different data formats such as JSON and XML. Now, if you're confused by that, do not worry. When I started my PhD, I had no idea about any of this either. And this is a big problem because lots of researchers are doing this sort of work, but no one is sharing their methods and codes, which is limiting accessibility and reproducibility of these studies to non-data scientists. Now, for me, I wanted to do this work over several different case studies and several different sites. And to me, it made most sense that I created an R package that myself or anyone else could easily use to extract these data sets. Now, for this R package, all you need to do is fill in a start date and end date, and then you have the option to add a keyword search, and also you can add a bounding box or a shapefile to limit the search to a specific area. You only need to fill in these 4 criteria, and then the R package will return the results to you in a nice tidy data frame, and you can use that for whatever analysis you want to. Before I start discussing the results, I want to first talk about limitations. Now, this is a bit topsy-turvy because normally limitations come last, but I want to talk about this with everyone understanding the caveats to these sorts of research. Now, when we use social media data, the results are only reflective of the users of the sites. For example, we did a study where we compared some different social media sites, and we found that some posts to Reddit were primarily about Europe and North America. And using this data alone would exclude the cultural ecosystem service relationships experienced from people from other areas of the globe. Though these findings are useful for guiding policy and practice, we should therefore not generalize these findings to the entire population and use these as complementary data sets to other sources of data. That being said, now I'm going to start talking through some of the papers that I have created and a bit of the future work that I'm currently undergoing and that's in review at the minute. So the first thing I want to talk about is image content analysis. We can use social media data to assess what people are actually photographing. We could manually look through all of the images and make notes about what people have taken photographs. However, this is quite subjective and time consuming. There are machine learning algorithms that can objectively state what features are visible in photographs. We can use these to find out what people are interacting with when undertaking, for example, recreational activities. In this study, I returned images within the USA, which contain the word hiking in their metadata. So as you can see from the top right corner in that figure, that's about 200,000 images I had for the time span that I was looking at. I then used the Google Vision Cloud API, which is a machine learning algorithm, to identify what features were in each photograph. So you can imagine doing that by hand would take a long time, but the Google Vision API labeled all 2,000 images relatively quickly. We found some really interesting results. So what we did is we took the Google Vision labels and we clustered the images into groups of scenery of what people photographed. And there were some really interesting geodiversity related landscapes that were coming out as clusters that images people were taking. For example, we had one cluster related to geological and arid landscapes, another to hydrological features, and another to mountains. Second, we can use textual sentiment analysis to assess how people feel and their opinions towards specific features. So sentiment analysis, for those of you who don't know, is a method of assigning a value or an opinion or a feeling to words. So in this case, we used a dictionary that provides words with a range of from positive to negative. So the most negative words get a value assigned of -5, and the most positive words get a value assigned of +5. We can use this information to assess whether the things that are highly photographed are also the things that had the most positive impact on someone's cultural ecosystem service experience. So in this paper, the most photographed things were things like plants. But actually, when you looked at the things that had the biggest positive influence on someone's recreational experience, it was things like buildings or coastal and oceanic landforms. So we can use this data to kind of test these relationships to see if people are photographing things they like because they're abundant, or if things that are more rare are actually having a more positive experience. Third, I'm going to talk about spatial analysis. So as I said earlier, these points are georeferenced, so the locations of these photographs have a specific location on a map. We can combine the locations of images with GIS layers to build predictive models that help us understand the distribution of the photographs. In this example, I looked at hiking in Wales. And then we use specific measures such as range in elevation, distance from the coastline, diversity of geology, diversity of hydrology, those sorts of things. And we built a predictive model to see what had the biggest influence on distribution of these images. And we found that distance to the coast and range in elevation had the biggest influence. But there was also some other accessibility measures such as distance to green space and distance to road. From this data, we can also extract the relationships between the variables. For example, as range and elevation increases, as does the likelihood of there being images of hiking. You may also notice from this image that being closer to the green space entrances also positively impacted the distribution of hiking photos. This again reinforces that accessibility also impacts recreational distribution, not just geodiversity. We can use the results of these studies to weight a geodiversity index. Now, an unweighted geodiversity index may highlight the most geodiverse areas, but it actually may not be the most useful geoconservation tool. By attributing our model's variable importance parameters to our geodiversity index, we can better map which areas have higher value for conserving for recreational activities. So as you can see from the weighted index, we've weighted the areas to places that have higher range in elevation and places that are closer to the coastline and other variables such as hydrology based on their importance to our predictive models. Now, this is maybe particularly important for conservation methods such as the UNESCO Global Geoparks program, which has some sort of focus on geotourism and recreation. In our example, we actually found that most areas of high geodiversity, weighted with our index, were within protected areas, such as the Geomon Geopark in Anglesey in the top left of the map, and also the Snowdonia National Park, which is also in the top left of the map. We did, however, find that there were some areas that weren't protected, and these results could be useful for guiding the opening of future parks or protected areas. The final case study I want to talk about is some work that I currently have under review. So this is using a novel method of assessing the viewsheds of where images were taken. So viewshed assessment basically looks at the surrounding topography and highlights all of the areas that are visible from that point. And by doing this, and by finding what is visible from where someone is standing when they take an image that they wish to then upload to social media, we can better understand what landscape characteristics are contributing to their aesthetic appreciation in this example. In this example, we're looking at a geopark in Cyprus. And from the results, we found that things like mineral extraction sites were highly represented in the viewsheds, showing that anthropogenic changes to geology and geosites may be very important in guiding people's aesthetic appreciation. So I just want to summarize some general findings that are kind of consistent over all of these studies. And what the take-home message is, geodiversity is really important in shaping how people interact with nature and the positive experiences they have. However, this isn't really a black and white result, and the interactions are really complex. For example, anthropogenic and biodiversity features and processes are also really important, so these also need to be accounted for. However, we can use these results to help inform geoconservation efforts. Just briefly, moving forward, there are some really innovative and novel methods being developed in computer sciences that we can apply to these data sets. There are new machine learning algorithms for helping to identify different features of photographs, such as different recreational activities or more detailed feature analysis. And there's also some new text sentiment classifiers and face sentiment classifiers that would be really useful for understanding how people feel. Here in these papers in this talk, I've only focused on 3 locations, the USA, Wales, and Cyprus, and 2 cultural ecosystem services, recreation and aesthetic views. However, this data could be applied to any cultural ecosystem service in any location. If you've been interested in what I've been discussing today, here are the references for my papers. And I thank you all for listening. I do welcome any questions. And if you're interested in using this data for your own studies, please feel free to reach out to me and contact me if you have any ideas for collaborations. My contact information is below. And thank you very much.
Thank you so much to Nathan. A wonderful penultimate talk for our conference, and I'm sure has got the brain cells going for people all around the world about how they might be able to apply those wonderful techniques to their areas. As Nathan said, keep your questions coming in the comments under YouTube, Facebook, or indeed on the Discord server, and we'll put those all to our speakers at the end of this talk session before we get on to our keynote speaker. But at that point, I'm going to welcome our final talk speaker of the conference to the stage. We've got Georgians joining us. How are you?
I'm doing good, thanks.
Very good, and it's a pleasure to see you. And Georgian's going to be talking to us about geoheritage and geodiversity as a tool for conservation in Jamaica. There are your stunning slides, and I'm sure a landscape that Nathan could analyze with his Flickr bots. But at that point, your 14 minutes begins. Take it away.
Okay, thank you for that introduction. I'm Georgian Dolphy. I'm an MPhil student at the University of the West Indies, and I'll be looking into geoheritage and geodiversity as a tool for conservation in Jamaica. So just to give you guys an idea of where Jamaica is, we're located in the Caribbean between North and South America. And I'll be focusing primarily on Eastern Jamaica in the parishes of Portland and St. Thomas. So this side of the island, as you can see, the terrain is pretty mountainous. It allows for a lot of interesting features on this side of the island. In this section here, we get a lot of rainfall. So this area is deeply forested and vegetated, and we get a rich natural and cultural heritage in this area. So this is just an image here of the mountain range here, the Blue and Jonker Mountains, which is a national park and a World Heritage Site. So what does the conservation landscape look like here in Jamaica? So as you can see here, these are some of my preliminary geosites, and some of them fall within the bounds of protected areas. So this large area here is the Blue and Jonker Mountains. However, a lot of them don't fall within protected areas, so we have to consider what some of the risks are, what some of the threats are to these areas, whether it be urban development, maybe agricultural practices. But this issue that I've highlighted here is not unique to Jamaica, where our focus is primarily on biodiversity and endangered and rare species, as well as culture and communities. And we find that geodiversity is completely left out of the conversation. There's currently no legislative framework that specifically targets geodiversity. However, it should be considered. It has potential to strengthen the capacity for protection in other conserved areas. But if we're able to present it in a way as a backdrop or something that underpins much of our cultural heritage and biodiversity, I think it could gain more traction. So the Blue and Jonker Mountains is actually home to the Maroons. These are the ancestral lands of fugitive enslaved Africans who had escaped the plantations and colonization. So they escaped or sought refuge in the hilly areas of Jamaica. So we get these communities still existing here today. And they sought refuge in these areas because it provided a lot of living advantages as well as warfare advantages. So they commonly settle in these areas because they want it to be inaccessible to the British in this case. So even for warfare, it provided them with the element of surprise. They were able to use the thick forestry and vegetation to hide and to attack the British at the time. So they used a tactic called guerrilla warfare against their enemies. And this instrument here is called the bang. And they would actually send these coded messages across valleys to each other. And to this day, we still don't know, we still don't know what those coded messages actually mean or stand for. So they've been able to maintain that part of their culture within the community. So obviously in these areas, we get high biodiversity as well as endemism. Roughly 40% of all of the species, endemic species in Jamaica, are actually located within this area. And Maroon communities have been able to take advantage of this, through farming. They've been able to use a lot of plants for medicinal purposes and so forth, as well as maybe extensive farming practices. So we can't talk about the Blue Mountains without talking about Blue Mountain coffee, which is world-class, expensive coffee. Volcanic soils coupled with the cool climate produce this world-class coffee that a lot of people have come to enjoy to this day. And also, lastly, we get evidence of some pre-Columbian indigenous groups that settled on this side of the island. So just to briefly take you through the geodiversity of Eastern Jamaica and to show how each of these categories here kind of represents major geologic periods in the evolution of Jamaica. So I'm going to introduce you first to the back Rio Grande area of Portland. In the upper reaches of the river, you get these wonderful exposures of these ruddists. This area is fairly inaccessible, but we have a great collection here at the University of the West Indies Geology Museum. Ruddists have actually been studied here in Jamaica since the 1800s. And since then, we've made some very interesting discoveries. For example, these two species here are actually more closely related to assemblages in Central America and even areas of the Northwest Pacific. And this species here, in particular, is actually a part of the collections in the Natural History Museum in London. So taking you into St. Thomas, where we get these exposures of basalts. So we get some pillar basalts in the area, as well as some plateau type basalts. This exposure is actually related to the Galapagos hotspot in the Pacific. And we can see rocks of the same kind of chemistry across the Caribbean. And together with the ruddists, these basalts, they kind of help to tell the story that the eastern side of the island had a different evolution from the western side. So we can make these correlations across Cuba, Hispaniola, Puerto Rico, even Curacao. And just a few kilometers away, these basalts are associated with a geothermal spring. So the story surrounding this area is that a fugitive enslaved African actually stumbled upon this spring. He had a wound on his leg, and he dipped his leg in the spring to kind of wash off the wound. And the next day he noticed that it had healed significantly. So since then, the area has been known for its healing abilities, its healing powers. So in the 1940s, I think this hotel and spa was established in the area. So people from all over the island can come and visit and experience the spring. So moving further up the succession into some rift deposits, this is the Nanny Falls. As you can see, we get some nice well-bedded shales and sandstones. And this deposit is kind of representative of a time when Jamaica was separated into different blocks and belts. But this site is actually named after a national hero here in Jamaica. She's called Nanny of the Maroons. She was instrumental in their resistance against the British and colonization. So she's actually buried. This is her grave here at the base of the falls. So this area has high cultural value. It means a lot to the Maroons. This area is actually within one of their communities called Moortown. So this area also presents a lot of geologic value as well as cultural value. And we get these thinly bedded turbidites in the dry river of Comfort Castle in Portland. And also associated with these thinly bedded turbidites, we get these wonderful trace fossils, which are indicative of a deep water environment. And also associated with these rivers are these snails that we call busu. And they're commonly used to make soups and stews in the area. You know, there's an entire festival surrounding this snail. But this snail is particularly popular on this side of the island because it's considered an aphrodisiac. There's an interesting little tidbit for you guys. So taking you along the coast in Black Hill, Portland, where we get a extinct submarine volcano. You can see some pillow lava structures in the area, some brecciated lavas, or even some vesicular basalts just lying around. And taking you along the coast of St. Thomas, where we get the amazing Bowden Shell Bed. So this deposit actually has over 800 different taxa, and it's probably one of the best, if not the best, neogene fossiliferous deposits across the Caribbean. Can find a variety of mollusks, which it's most known for, as you can see here, corals, bryozoans, forams, and so much more, as you can see. So along the coast again, taking you into Turtle Bay Cove in Portland, where we get these lovely geodynamic features. This is a mixed plastic and carbonate system, where we get these cliffs, these small waterfalls associated with them, get arches, stump stacks, and just a wonderful area with a lot of educational value as well. And kind of just to cap off the succession, we get exposures of these Pleistocene reefs. So this exposure, these corals here, we can actually see in our reefs today. This species is Porites furcata, but some exposures show some extinct species, which is this one over here. And this deposit kind of signals a time of an extinction event, which affected coral reefs across the Caribbean. So just some closing statements. As you guys can see, I'm still in the preliminary stages of my study. There needs to be more evaluation to determine geosites or proper geoheritage locations, understand what the threats are, how vulnerable these areas are to degradation, and hopefully we can encourage the inclusion of geodiversity and geoheritage into our conservation framework in Jamaica. Thank you.
Thank you to Georgian. I think if ever there was an argument for stopping virtual conferences and going back to in-person ones, it would be the wonderful geoheritage that Georgian has just showed us all. And hopefully you'll be organising some form of international conference on geoheritage so we can all come and see. But at this point, I'm going to invite Nathan back on because we've got questions. The questions are rolling in for both of you. If you've got any questions, you've got a few minutes left to put them in, people at home. Where should we go first? So many questions. Well, firstly, we've got lots of praise for your talks. Helena was really praising your talk, Nathan, and then Ben, loving your talk as well, Georgian. And Ben asks for you, Georgian, can the geoheritage be framed in a vision of the locals so as to strengthen their culture, and so geoheritage can approach the area in a respectful way?
Definitely. If you talk to these people from these communities, you notice that they have high regard for their environment, for their surroundings, and there's a strong sense of place. So last week, I actually got the opportunity to present to them the ideas around geodiversity and geoheritage, and they're actually pretty, receptive and kind of excited about the idea. They're excited to know even the age of the rocks and how we could kind of tell what the age of a rock is. So I think that's a great starting point, and there's definitely a lot of opportunities to make linkages between their culture as well as geodiversity and geoheritage.
And I'm going to add a personal follow-up to that question to ask, you talked about the lack of recognition for geodiversity when compared to biodiversity in Jamaica. Now, I note that the Minister of Culture, Gender, Entertainment and Sport, Olivia Babsy-Grange MP in Jamaica, she has commented publicly on International Geodiversity Day and how it's a great way to show off, in her quote, the diversity of Jamaica's own substrates, inclusive of various limestones, volcanic rocks, and a range of soil types, have provided the foundations for key habitats of globally significant species endemic to Jamaica. If only all policymakers talked about geology so richly. Do you think this might be an opportunity to get the protection that you're after?
Yes, but also there still needs to be more education around geodiversity, or even the geosciences in general, even at the community level or at the local level. So I think we have to establish that first before we can make big steps. So yeah, I think that would be more important at this stage, but that's definitely a great sign. Yeah.
A very good answer to the importance of education. We're going to zoom over to Czechia because we've got a question from Lucy for Nathan. Do you consider or plan some citizen science projects? Because obviously you are obtaining all this data from the people, and it might be an opportune moment for some citizen science.
Yeah, so one of the interesting things is because social media is an interactive platform, there are potentials to put things out there and get responses from people. So websites like Reddit are much more of a discussion-based website than things like Flickr. So you could go onto these websites and post images or post questions and get people really having a discussion about these sorts of things, and then using that information to inform policy or decisions or anything like that. And then you can also, there's been quite a few studies that have actually gone and messaged people from these sites. So you can send messages of surveys to people's inboxes. So for example, in Flickr, you have an inbox, and they've got quite high response rates. People using these social media sites are uploading their pictures for a reason. They want to show people what they're taking photos of, and they're really enthusiastic about engaging. So there is definitely some scope for further work using that sort of thing if people are interested.
Excellent. And we've got another question for Georgian from Rosangela. If I'm the person who keeps talking about Geodiversity Day, then Rosangela is quite rightly beating the drum for the geodiversity of soils. Do you have an inventory of pedosites or soil geodiversity in Jamaica?
Well, our local government institution should have a distribution map or some kind of inventory of the soils. However, the problem with this side of the island, it being very mountainous and rugged and so forth, is that there are a lot of gaps in the record. So I'm not completely sure, but yeah, there should be some kind of inventory or information from our local government institution.
Excellent. Some potential there for future work. A final question I've got for Nathan. Do you think your work has some application within the wider, broader tourism industry to help shape how certain geoheritage features are designed from the perspective of interpretation? For example, you were talking about should we all be making sure that there's a variety of ranges of trails? You know, you were talking about how the photos were more likely if they were near the start of a trail. And how do you think you would go about getting your wonderful research out there to people in tourism who perhaps don't think about rocks?
Yeah, so one of the things that we pick up on in that paper is how we could actually use the spatial distribution models to better design trails, for example, alleviating pressure on at-risk geosites by ensuring that those trails don't go close to the sites, but offer still a nice vantage point or a viewpoint that people can enjoy them from. And I think, excuse me, I think there's a really big application for this sort of thing, and using spatial data to help understand people's movements and understanding what people want, and better designing geoparks to actually give people accessibility to geosites without putting them at risk.
Excellent. Well, thank you both to our final speakers for both their wonderful presentations and indeed their questions. We're not finished yet, though. We've still got a keynote. So thank you once more to Georgian and to Nathan. Just before we get to our final keynote speaker and our final event of this year's OxGVC, a few announcements and thank yous. Firstly, I want to thank ProGeo, the International Association for the Conservation of Geological Heritage, and IAPG, the International Association for the Promotion of Geoethics, for the support they've given to this meeting, getting the news out there and helping advertise and get people involved. If it wasn't for organizations like that, we certainly wouldn't have the number of delegates we have signed up, and indeed the number of abstracts submitted and people joining us from more than 70 different countries all around the world. I also want to thank the Oxford University Museum of Natural History for its continued support for this online event, and also the Charnwood Forest aspiring UNESCO Global Geopark, who have supported us by the provision of this wonderful system that allows us to beam to you all over the world. Now, we have a few more things to say at the very end, but I think at that point we will get on to our keynote speaker. So I'm going to invite Priscilla onto the virtual stage. How are you, Priscilla?
Fine, thank you. Can you hear me okay?
You're coming through loud and clear. Now, I'm really pleased to welcome Priscilla Groot, Professor Priscilla Groot, to this meeting to give the final keynote talk and wrap up the meeting. Now, I just want to, you might not have come across Priscilla before, but this seemed like a good opportunity to join together people who are working on very similar things and bring us together in our love of geoheritage. And Priscilla's biography is so long, I can't possibly have remembered it all off the top of my head, so I'm going to have to read on my other screen. But just to give you a quick background, Priscilla has been director of the Minnesota Geological Survey. She's been vice chancellor of the University of Nebraska, served on the National Academy of Sciences board on the International Scientific Organization, and has also been involved in international organizations, which I'm sure we've all heard of, including the International Union of Geological Sciences and the International Union of Geodesy and Geophysics, and indeed was the US nominee for the president of the IUGS in the spring of 2016. I must say, though, my favorite fact about Priscilla is that I have to start with a separate fact first to put it in context. Did you know there are nearly 6,000 named minerals in the world approved by the International Mineralogical Organization, but less than 100 are named after women, and one of those is Priscilla Gruite. She's one of the few women who has a mineral named after her, and I think that's wonderful. But we should, of course, hopefully one day you will be one of many thousands. But for the moment, one of the few women who has a mineral named after her, and very richly deserved. But today, Priscilla's going to talk to us about geoheritage and geoconservation in Antarctica. We have heard about the topic all around the world from the 7 inhabited continents, but very rarely do we hear in these meetings about what's going on in the uninhabited continent of Antarctica. So what a wonderful way to wrap up our meeting. So Priscilla, thank you so much for joining us from the other side of the Atlantic. The floor is yours.
Thank you. I see that something is gone amiss actually in the organization of my slide here, but we'll manage somehow. I hope that's not going to be a predictor here. But Jack, I wanted to thank you so much for the invitation to speak. My title is Geoheritage and Geoconservation in Antarctica. And I really wanted to congratulate Jack and everyone on this fantastic conference and wonderful talks. That talk on Jamaica was just amazing. So I join everyone in complimenting the presenters and the organizers of this meeting. My presentation, I have to admit, first off, I have never been to Antarctica. So the plus side of that is that this should encourage you, if you've not been to Antarctica, you can still work on Antarctic issues and be interested in Antarctica. So I hope I will inspire some of you to pursue issues in geoheritage in Antarctica as a result of this talk. So what I did for my talk was I recruited 3 co-authors who've had years and years and years of experience in Antarctica, and I'll be telling you about them. I'm going to talk about how Antarctica is kind of managed, as it were, under the Antarctic Treaty. The lands and oceans south of 60 degrees fall under the Antarctic Treaty. And I'll be talking about the protocol on environmental protection and the annex of that, which is most important to geoheritage, which is the annex on area protection. The International Science Council, as you know, Jack mentioned the IUGS, the alphabet soup of geological unions. The Scientific Committee on Antarctic Research is the Antarctic component of that. And so it's very important, if you're interested in Antarctica, to know about how that committee works and how scientists are involved in advising on Antarctic policy. I'll talk about the Antarctic Specially Protected Area. My husband, Ed Grew, one of my co-authors, and his colleague from Australia worked in an area which became the first area that was declared as a specially protected area for minerals. That is not biodiversity or something, but actually for minerals. I'll talk about the SCAR Action Group on Geoheritage and Geoconservation, which is the most important group for those of you interested in geoheritage to follow if you're interested in science policy in Antarctica. And then finally, I'm going to talk about potential Antarctic geosites, because the process is just starting in a sense of trying to apply what's happening with world geoheritage to Antarctica. So just first a little bit about myself. As Jack mentioned, I became vice chancellor. I was actually hired as vice chancellor at Nebraska in order to get the polar ice coring contract back to Nebraska from the University of Alaska. So when they hired me in 1993, I went on what was called the National Science Foundation Job Walk, which was being flown to the summit of the Greenland ice sheet, where they had just almost completed drilling through the ice, a 5-year program of drilling through the ice to bedrock at the summit of Antarctica. So here I am, and I borrowed an Antarctic parka from Sam Trevis, who went back to IGY, International Geophysical Year days, to Antarctica, and I had a wolverine fur hood on it. That was for good luck. But at any rate, in Nebraska, although we're in the middle of the continent, we have actually had the National Office for Polar Ice Coring. And most recently, we're involved in the sensitivity of the West Antarctic ice sheet to the 2 degrees centigrade scenario, drilling that's going on in Antarctica. My co-authors are Kevin Hughes from the British Geological Survey. Sorry, Antarctic Survey, not Geological. Antarctic Survey. I automatically say Geological Survey, sorry. Christopher Carson from Geoscience Australia, and my husband, Ed Grew, in University of Maine. So first, a little bit about Kevin Hughes. He is a very important player, as we say, in Antarctic geoscience. He is environmental research and monitoring manager of the British Antarctic Survey. He's actually a member of the United Kingdom delegation to the Antarctic Treaty consultative meetings. He's vice chair of the Antarctic Treaty Committee on Environmental Protection. It's the important environmental committee. And in this picture, it's shown he's counting penguins, Adelie penguins, on an island in the Antarctic Peninsula. His most important component in terms of this talk, though, is going to be his role as secretary for the SCAR Action Group on Geological Heritage and Conservation. He served in that role from 2015 to 2021. He's just left the committee in order to take on a new lead position on sustainability and impact mitigation. So he's very active in Antarctic issues. Co-author Chris Carson was the one who worked with my husband. This is one of my husband's favorite photos. And I know Ben, thank you, Ben, for the big plug at the beginning of the meeting about my talk. And Ben showed a picture of the resilient penguin. Well, here is a penguin that I think looks a little bit either disgusted that he's not the center of attention while Chris works on rocks or whatever, but maybe he's being critical of the geologic field notes. But I just love this picture. Where this is my penguin picture to try to compete with Ben's resilient penguin. So here are Chris Carson and my husband on Christmas Day celebration, their Christmas dinner in their camp on the Ingrid Christensen Coast in East Antarctica. They're two geologists. This was the Australian Antarctic expedition when they were there in 2003. Here's a picture that Ed took of Chris. And the reason I wanted to show this is if you look in the back, you can see the continental ice sheet, the ice that if one of the big issues to remember when you're considering things in geoheritage in Antarctica is that almost all the land area of Antarctica is covered by continental ice. Only 0.3% is exposed land. So that is the continental ice sheet coming down to the ocean in East Antarctica at the horizon there. And then you can see Chris is standing on the land area. So as a result, what happens is that the impacts of whether it's geologic research, tourism, stations, or whatever get concentrated into a very small area in the ice-free areas of Antarctica. So here's Larsman Hills where they were camped. If you can just barely see in the circle, there are two little red tents, and you can just see how you're kind of by yourselves when you're in Antarctica like this. So they were 120 kilometers from the Davis station of Antarctica. They were supplied by helicopter. And so they spent 2 months at this camp doing everything on foot, going around and doing their geologic mapping and study of the minerals there. So my husband, Ed, that's an introduction of Chris and Kevin. Then the third co-author is my husband at the University of Maine. And this actually is his 50th anniversary year of his very first trip to Antarctica. So if you can imagine in 1972, that was back in sort of the Nixon-Brezhnev days under the Antarctic Treaty, leaving for 16 months to be with the Russians with a winter over in Antarctica. This is what he did. He was based at the University Polar Center at the University of Wisconsin at the time. And so he met the Russian ship at Montevideo in 28 November 1972, and he got off the Russian ship in the Canary Islands 2nd of April 1974. So in the meantime, he went down to Bellingshausen, which is collected volcanic rocks on the Antarctic Peninsula, and then went to Novorossiyskaya, another Russian station for field work, wintered over at Malajuzhna Station, and then had 2 summer seasons at the Prince Charles Mountains Amory Ice Shelf area in East Antarctica. So here is Ed on another expedition in 1978. He went with the Australians. He's interested in the high pressure, high temperature metamorphic rocks, the Precambrian rocks of East Antarctica. So that's why he had to go with the Japanese, the Russians, or the Australians to get there. But here he is at Dalwitz Nunatak, which has actually been suggested as a potential geoheritage geosite because it was the world's first locality for the mineral assemblage sapphire plus quartz, which translates into implying very ultra high temperatures of metamorphism that are not found elsewhere on Earth. And this was first reported by Dalwitz in 1968, and then Ed was there with the Australians in 1978. So here they are camped on a glacier, and you see you make your own furniture in Antarctica. So as a result of having gone with the Soviets in the winter rover 72-74, Ed actually got a peak named after him. We actually do have his and her minerals, Priscilla Gruite, and he's got an Ed Gruite mineral too, but he also has a peak. So he got Gru Peak named after him. And these are two Antarctic scientists from the University of Maine who actually got near this peak in 2020, just before the shutdown, and got us a picture of Gru Peak. So for our souvenirs. Well, those are my co-authors, so they helped me. So I haven't been to Antarctica, but I relied on them to help prepare this talk. So now I'm going to turn to the treaty structure, and the real reason this is important is because, as I mentioned, Antarctica is really special. It's not under the UN. All the policy things are done under the auspices of the Antarctic Treaty Structure. So the treaty was first signed in 1959 by 12 nations. This is a little graphic from the British Antarctic Geological Survey with the flags of the nations in sort of order. The inner circle are the 12 nations that signed in 1959. And then the consultative nations that joined are the next ring. And then the outer nations are the non-consultative ones, which I'll go through. So the 12 initial ones and then the consultative parties to the treaty are the ones that are currently involved in decision-making in Antarctica. And they also are signatory, all of them are signatory to what's called the Protocol on Environmental Protection to the treaty, which was initially signed in 1991, but took effect in 1998. So oops, get the next slide here. The non-consultative parties, that is the next tier of countries, they are the ones who attend the treaty meetings, but they are not involved in the decision-making. And you'll see some of these have asterisks and some do not. And the ones with asterisks are the ones who also signed that Protocol on Environmental Protection. So as of today, there are 42 parties or 42 countries that have signed the Protocol on Environmental Protection. And the real reason that is important is that's under which we're going to have these protected areas that I'll be talking about. So the Protocol on Environmental Protection designated Antarctica as a, quote, natural reserve devoted to peace and science. Any activity relating to mineral resources other than scientific research shall be prohibited. However, impacts resulting from tourism and research activities, including overcollection, since that signature, have increasingly degraded important geoheritage and geodiversity sites. So as a result, there's been concern and a need to protect areas and to take environmental measures for environmental protection. And so the way this works structurally under the Antarctic Treaty is you have the protocol, and then there's 6 annexes to the protocol, one of which is Annex 5, Area Protection and Management. And then under Annex 5, there can be Antarctic Specially Protected Areas, ASPAs, and Antarctic Specially Managed Areas. So the science policy part of this is operated by the Scientific Committee on Antarctic Research, or SCAR. So this is that thematic organization of the International Science Council. It was created at the time of the International Geophysical Year back in the 50s. And the purpose of SCAR is it provides objective and independent scientific advice to the Antarctic Treaty Consultative Party. So it's very much like in your individual countries, you have your National Academy of Sciences, in which scientists provide advice through the academy to your national government on various issues, whether it's climate change or geology or biology or whatever. So the science, the Antarctic component, the Antarctic equivalent to that is SCAR, the Antarctic Committee. So SCAR has 43 member countries, And also there are 9 scientific unions that are members of SCAR. So we have the International Union of Geological Sciences. That's the one that runs the International Geological Congress, the International Union of Geodesy and Geophysics, quaternary research, and so on. So this is the structure how Earth scientists have input into SCAR. As I mentioned, that picture of Chris that I showed you that had the continental ice sheet, you can see that the map of special protected areas, although it's hard to see in this, but you see the little colored dots and how they're all along the coast. And the reason is it's that ice-free area problem, is that everything gets concentrated into the very, very limited ice-free area. And that's why there is such a concern about in Antarctica about what is happening, where the Antarctic stations are, and what happens where research is going on. And the Storness Peninsula, which is the first area designated for minerals, that is the one that where I showed you the picture of Ed and Chris Carson in their camp. That is shown on the map. So the Larsman Hills, this area in East Antarctica where that dot was, the first designation in that area was an Antarctic Specially Managed Area, ASMA, which was designated in 2007. And one of the things to notice about this ice-free area on the coast is all the red stations. So there's a Chinese station, Zhongshan, there's a Russian station, Progress, there's La Rocavita, which is a summer station, which is Australia, and it's also Romania's first station, and then Bharati station, which is a station of India. So you see that there obviously is a need for coordination when you've got all these year-round stations in a very small, comparatively small area. And that was one of the reasons that the specially managed area got designated. So then Ed and Chris worked up the mineralogy and geology of the Larsman Hills and the Storness Peninsula. And then Storness, this area, the area, the large, it's a little bit hard to see here, but sort of the whole map area is mostly the managed area. You can just see that faint line around it. And then you can see the Storness Peninsula, which is the specially protected area. That is the one that is designated for special protection for the geologic or the mineralogic resources. So the reason they were able to get the very first mineral designation for a protected area in Antarctica is because of the astonishing abundance, variety, and the crystal size of the extremely rare minerals at this locality. Borosilicates, that means silicate minerals with boron, and phosphate minerals that occur nowhere else in the world. For example, a new mineral my husband discovered, boralsolite. He named it for boron, aluminum, and silicon, boralsolite. Some of these others are kind of big mouthfuls for mineral names. You see stornosite, that was a mineral discovered here, named for Storness Peninsula with yttrium. And then choponite is an interesting one because that's named for a famous French mineralogist. And Ed found choponite, the phosphate, at this locality. It's been found nowhere else in the world. And then he borrowed a meteorite from Antarctica from one of the repositories. The meteorite was collected on the other side of the continent. And in the meteorite, he found choponite. So choponite at the moment now occurs in one locality on Earth and one locality in a meteorite so far. So when this area was protected, there was a big article in Earth magazine by Ed and Chris on protecting mineral treasures in Antarctica. And it made a lot of news because a mineral site, not just a biology site, was selected for protection. So as a result, we don't know as a result, but it was the same year, later that year, I think we think because of the attention that this brought to geosites, to geological sites, the Scientific Committee on Antarctic Research, SCAR, established in November 2015 a new action group on geological heritage and geoconservation. So that's where all you guys come in. Geoheritage finally makes it to Antarctica. So the action groups are topical groups, the short-term topical groups that are established by SCAR to assemble scientists to work on issues. So the SCAR Action Group on Geological Heritage and Conservation, that's one that you need to know about if you're interested in Antarctic geoheritage. The current chair is Dr. Reguero from Argentina, who's a vertebrate paleontologist. And Dr. Carcavilla is the vice chair from Spain, who's a specialist in geologic heritage. The secretary job is currently vacant because Kevin Hughes, the co-author of this talk, Kevin Hughes was the secretary 2015 to 2021. And actually, Chris Carson was the first chair of this group. So currently the committee has a vacant chair, and then there are 9 members from different countries and 7 members from making the community of interest list. So just to give you a flavor of another kind of area that has been designated, one of the reasons why they're interested in starting this geoheritage group, this is a locality, a very different type of specially protected area, one for fossils. And this was the Mount Flora locality. Actually, there was an earlier way of designating sites, which was a site of special scientific importance. And at 1989, this special fossil site got that designation and then was converted into a specially protected area in 2002. So it was one of the first that came in after the environmental protocol. And this was very important because it was one of the first fossil floras that was discovered by the first explorers coming to Antarctica. You remember hearing about the Gondwana southern continent. And so this goes back to dinosaur days of the Jurassic. They just did a new radiometric dating of these rocks, which found that they were 164 million year old deposit. You can see the very beautiful fossils. Unfortunately, this area is now very much accessible to tourists. It's a concern about souvenir collecting, concern about pressures on this area. And so this is an example of one of the areas that's under the new system of geoheritage. So for potential other sites, here's one more. I thought I'd use this slide right here because another paleobotany type of sample. This is one that Kevin Hughes included in an article that he did on potential geosites. This one is another area of Antarctica where the beautiful fossils of southern beech. You can still see real southern beech trees in New Zealand, but these would be about 3 million year old fossils from Antarctica. Of course, they're very much of interest for paleoclimate studies. So to give you a flavor of the kind of issues that are being worked on by the Geoheritage Action Group, one is the whole issue of how do you identify Antarctic geosites, the methodology for that. They've also developed a new environmental code of conduct for geoscience field research in Antarctica. And it's everything from, trying to get people not to move rocks around. In other words, you don't want people to be carrying rocks from one area to another and dropping them so that geologists come around later and think, things are in the wrong place. To over collecting things like just the general, good manners, good scientific practice. It's they involve the geoethics people and everybody in developing this. So they have a new code of conduct that I think many of you would probably be interested in looking at. Another issue that they've dealt with is they're trying to make a more accessible list of national repositories, because the whole idea is we should be using our samples that have been collected by previous expeditions, whether they're meteorites or fossils or rocks or whatever. And as a museum director, a previous museum director, I know how important it is to have our databases be accessible to users. And so what this group is also, they feel it's very important that there be much better centralized listings of repositories, so that, say, when my husband wanted to borrow a meteorite that had a phosphate in it, he'd know where to go and somebody didn't have to go collect it at some other place. Then also, they've actually tried out the procedure for identifying geosciences, and the first exercise they did was they tried out the area of Marambio Island, or the other name for it is Seymour Island, the Antarctic Peninsula, and tried out making parameters and then trying to fit in what the aspects of that to see whether it made sense for a methodology to identify geosites. So the code of conduct, the that has now been officially endorsed. Oops. That's the code of conduct now has been officially endorsed because it was presented to the 43rd Antarctic Treaty Consultation meeting in Paris in 2021, and the Committee on Environmental Protection signed off on it. So that is now in effect as their voluntary guidelines, but it has been approved by that Scientific Committee on Environmental Protection. So if you would like to see what this is and see whether you think it's a good document or whatever, these documents are always available for you online. And so this is one that anyone interested in geoheritage, I'd really suggest you might be interested in using. And if you're teaching a course on geoheritage, it would be very good for students to analyze. The other working paper, this is a working paper still. It's not been approved officially by the Committee on Environmental Protection. It was discussed at their last meeting, but this is the methodology suggested for a systematic identification of globally important geological sites in Antarctica. It's this whole issue, the whole geoscience community now worldwide. We're all kind of dealing with, what methodology do you use is the best to identify these special sites. So if you're interested, this is another document that I'd recommend that you study. So as an example, the committee as I mentioned, tried out just using setting parameters and then see if they worked, working up a proposal for the Seymour Island case. And so the important thing about the Seymour Island or Marambio Island in the peninsula is that it has an incredible exposure of the transition between the end of the Cretaceous and the Paleocene. That is the end of the Mesozoic, beginning of the Cenozoic, or the extinction event of the dinosaurs. And that event is right in the middle of a continuous sedimentary sequence. So I don't know if you can see it on your screen here, but this is a picture of the boundary. There's this sort of a yellow line in the middle of that brown formation. And you can see on the right where the extinction event is in the middle of a sedimentary sequence. So the advantage of this is that the scientists can then look exactly to see what forms of life and fossils are present below that event and above that event in a similar sort of geologic sequence. So it's a really, really important way to be able to study that boundary. Another example of a possible kind of geosite would be meteorite localities. Now in Antarctica, there are so-called blue ice fields which concentrate meteorites. And the reason is, as you can imagine, the big continental ice sheet and meteorites falling on that ice sheet all over for hundreds of thousands of years. Where do the meteorites go? Well, the ice is flowing to some extent horizontally. And so where you have the ice flowing, if the ice flows to a place where you have ablation, you start losing the ice, you're going to just leave behind the meteorites that have fallen on that ice. And so these blue ice areas are where the ice is being lost, and it's concentrating whatever it was sitting on that ice or sitting in that ice. So that's why you got these tremendous concentrations of meteorites. And one of the biggest sources of meteorites now in the world in recent decades, of course, has been Antarctica. But the concern then is, what should be policy about collecting these, and what should you do about possibly considering future generations or whatever. This is a good example of something that's going to need geoheritage consideration. Another type of potential geosite, again, this is one from Kevin Hughes's paper, and I'll give you the reference to later, are the dry valleys near the United States McMurdo Station. And you can see here this really weird rock weathering called Tafoni weathering, where if you have a rock mass that's sitting out in the Antarctic climate for a very, very long geological time, you get these very strange sculptural effects on the rocks. And so these would also be considered potentially for geoheritage consideration. So going back to my husband, Ed Grew, and Chris Carson, there's been so far only one area in Antarctica that's been designated for minerals. And so Ed is interested in possibly, well, maybe there could be another area that could be proposed as a special geoheritage geosite for minerals. And this site is we'll refer to it as Casey Bay. You can see it's in Enderby Land, Antarctica. Again, it's on East Antarctica. And the reason this one is of interest is because this is Ed collecting. This was actually on a Japanese expedition, and this was taken by one of the Australians. This was one that was taken by one of the Australians on the Japanese expedition with Ed. He is studying pegmatites, which are if you think of a lot of gem minerals like beryl, it would be an example of minerals and beautiful rock crystals. Sometimes are in pegmatites. So, but however, these pegmatites are extremely rare. They're very, very high temperature beryllium bearing pegmatites. And so Ed has taken some of the parameters for this site and tried to fit them into the categories, the methodology that the action group, the SCAR action group, is using. So, for example, representativity, mouthful. This is the most representative and developed example of high temperature beryllium mineralization in the world. There's no other place like it that has these minerals. And it is a type locality. In other words, that's another consideration. A type locality for the mineral fumarolite. The degree of scientific knowledge, there have been a lot of papers written about it so far. The state of conservation. Now, this is an area that isn't as high, is vulnerable to tourists. It's a quite isolated area. And actually, I think as far as is known, the only people who have been there are Ed on his first trip with the Australians and then a second trip with the Japanese. But still, it is a very unusual area in terms of minerals, even though it doesn't have the tourist problem. And then the other aspects of their framework for considering geosites are whether the material is visible and observational, and it is in this case. It's in an ice-free in the summertime. They're rare. It's very rare, unique association of high temperature beryllium minerals, so that fits that. So this is just an example. You can take an area that maybe you're interested in Antarctica and see whether you could fit it into these parameters that have been suggested by the action group as how to evaluate geosites. So another possible geosite would be the famous Mount Erebus. You probably heard about Mount Erebus because it's a volcano that's fairly near the U.S. Antarctic base. It has an active lava lake in the summit, and excuse me, there in the most recent compilation of World Heritage volcanoes by the International Union of Conservation of Nature, Thomas Casadevall, who is the U.S. Geoheritage, he's chair of the U.S. Geoheritage Committee under the Academy structure. He had pointed out to me that in the book says they don't actually list Mount Erebus as a World Heritage volcano because they can't, because the World Heritage Program doesn't cover Antarctica since Antarctica is under the treaty. But he said that he feels that if although it's not covered by the World Heritage Convention, that it otherwise it would certainly have a high likelihood for inscription if it could be nominated, because it's so historic. It has an active lava lake, and it has everything else going for it for geoheritage. So what are next steps? Well, I asked the vice chair of the SCAR action group, told him I was giving this talk, and he said I should inform you the following. And he's Dr. Carcavilla at the Geological Survey of Spain. And he said that the transition now is in progress from the SCAR action group to the new SCAR expert group. And I mentioned that action groups are short-term study groups under SCAR. And so they consider geoheritage so important that then now they're going to move it to the next big category, which is an expert group. So the time for an expert group would be something like 6 to 8 years now that that will succeed the previous action group that I've been talking about. And so that is happening next month, actually. In July 2022 are the next business meetings for the Scientific Committee on Antarctic Research. And so the committee is going to be the action group's meeting is going to be chaired by the current chair, Dr. Ruggiero, and they're going to be talking about the topics, membership, leadership, and so on, about the future of this group. So I'd like to recommend, I always like to say, what would I do for my students? Recommended reading. If you'd like to learn more about this talk, because this is the big reference I used to prepare this talk. This is a review article on Antarctic geoconservation that was the lead author is Kevin Hughes at the British Antarctic Survey. The second author, Professor Lopez Martinez, was the president of SCAR, the president of the overall SCAR group. He's past president of that. And Jane Francis, of course, is the British Antarctic Survey, and then Louis Carcavilla, the vice chair of the action group. So this is kind of the wonderful reference if you want to learn more about geoheritage and the issues in Antarctica. And then I'd like to encourage you, since we have unfortunately, thanks to COVID, but there's the silver lining for some of the COVID things is that the SCAR meeting, the Open Science Conference, is going to be virtual this year. So you don't have to scare up travel funds to go to India to go to the SCAR meeting. And so the SCAR meeting, you can actually register online for the SCAR meetings. The way it works is they have an open science conference that's open registrations, and then it's a fairly nominal fee. I think it's about $25 or $30 US for the registration for online. And then in association with that conference, they will be, first of all, the SCAR business meetings, 27 to 29 July, where that whole issue of the action group going to the expert group will be considered. And then the big SCAR meeting is after that. So that's kind of a quick introduction to geoheritage in Antarctica. And I hope that you will consider possibility of getting involved, because you're already involved in geoheritage issues in so many different areas of the world. And there are a lot of opportunities now that geoheritage is kind of starting to take off for Antarctica. There are a lot of opportunities for fresh ideas. And this is I think the group that could really contribute. So thank you very much.
There we go, everyone. We can not only learn all the wonderful things from Priscilla's talk, but we can get involved ourselves. So I certainly will be looking up #SCAR 2022 and see what's going on there. Well, we've had some questions come in. If you've got any more, do put them in the comments. Thank you once again, Priscilla, for a wonderful talk. Firstly, we have a question from Ben, who asks, what about the intangible geoheritage? And he puts in a subsequent comment, what about the amazing intangible information, such as the sub-ice topography? As most can't visit Antarctica, would such areas be best made available as virtual visits, avoiding actual visitors?
Well, I think that's a terrific idea. I'm not sure that they've really considered that yet. So now that's a really super idea. And the thing is that so much of geoscience, we haven't really, taken in all the changes that have happened the last 2 years and the whole accessibility. I mean, the whole reason that I got invited to do this talk is because I was invited to give a seminar at Boston College where I taught 50 years ago. And I was invited because they did Zoom. And then Jack turned out to attend because I'd asked Jack for help. So the thing is, none of us have, I think, really, grasp the possibilities here for the kind of question that Ben asked, and that's I think a really good a really good idea that should be pursued. I mean, what kind of things? Because I think a lot of people are kind of turned off on Antarctica because they'll never get there or whatever. And the Antarctic folks are trying to work with that. They have a new book out on the Antarctica and climate change put out by SCAR, and the little tagline is coming to a postal code near you, which is the whole idea that even though we're sitting in the middle of Nebraska here, and people say, why on earth are you involved in Antarctica? The thing is, our agriculture is going to be affected by what happens in the global system involving Antarctica, and so it does come to a postal code near you. So I think ideas like your, Ben, it's a great idea, and I don't think they've thought of that yet. So go for it.
Excellent. Virtual field trips becoming even more popular. You mentioned the threat to geosites from researchers, which is often a thing that's overlooked or underplayed elsewhere. Do you think Antarctica could be a place where we learn more about the threat that research plays on an area and how best to manage that elsewhere?
I think that's very important. I mean, I think probably in our geological education, there's of course a growing geoethics consciousness and a professional ethics consciousness that perhaps wasn't there in the old days. And I know when I was coming up, I mean, it was a grad student, we would go to places and people would complain about Professor X who mined out the whole outcrop. And so the issue of over collecting and ruining outcrops for the future is not new. And it's just that and the problem, of course, in Antarctica is those are all voluntary guidelines as well. So we're going to have to rely on people, as in other areas of life, being more knowledgeable, more conscious of our responsibility to others and our responsibility to future generations. So I don't think that passing rules isn't going to stop people from ruining outcrops, but there needs to be a much greater awareness of this, and especially in Antarctica. I mean, basically, you think of the first people exploring Antarctica, there weren't people there before, so it isn't like where there've been like 10,000 years of people in an area that before you that you may not be aware of, but they were there. And so all that then is changing with the exploration, but we're going to have new areas exposed with more ice melting. And those pristine areas are going to have to be handled in a responsible manner.
Now, one thing I wanted to ask you about, the talk you mentioned before that you gave for the college was around policy engagement with science, and you've got a lot of experience with that. Of course, the beginnings of the Atlantic Treaty System all those years ago in the Cold War, bringing nations that were pretty much at each other's throats together in this one area of the world. It was seen as almost geodiversity was underpinning a little area of peace at that time.
Yes. Yes.
Do you think things like the Antarctic Treaty System and international cooperation around geodiversity and other geoheritage and other aspects can continue to do that? Because that feels to some a little bit more distant these days.
Well, those are that continues to be big issues, and that's where I think the International Science Council is helpful. I mean, for example, right now there are major policy issues on how to handle the situation of refugee displaced scientists and how to handle scientists where you've got countries in conflict and the whole issue of openness in science and so on. During the Cold War, I mean, that was and I was in Prague at the time of the Soviet invasion in 1968 because we had the Geological Congress in Prague, and I was staying in the apartment of a Czech geologist friend, she'd invited me to stay in her apartment, and and so after that, I know there were people said, well, you shouldn't have anything to do with Russian scientists after this. And the next year, I was invited to go to Lake Baikal to a geological excursion on Lake Baikal, and I went with Professor John Rogers from Yale and some other people. And there were people who felt that we shouldn't have gone because of the situation. So it comes down, I think, to a lot of personal choice and how you, whether how you feel about being on science versus in the context of very, very painful and difficult international situations. And there's probably no real good solution to that. But I think the Antarctic Treaty is often held up to an example of something that went on during the Cold War. I mean, when Ed was there, he was there like 72, 74, 76, and things were not all that great from the standpoint of the Cold War when he was there. So I think science, but it's so much a matter of individuals as well, and how you relate to your international colleagues.
Absolutely, some important points there. And just to wrap up, we've had lots of messages thanking you for your presentation and your talk and your answers to your questions. Sylvia and Elaine on the Discord channel thanking you for your presentation. So and Ben says he's going to get back on Google Earth and check out those images of Antarctica. So thank you, Priscilla, once again for a wonderful keynote wrapping up the meeting.
Thank you. Bye-bye, everybody.
So all that remains for me to do is a few final thank yous. I want to thank the other co-organizers, Helena and Lubomir and Taha and Lucy and Catalina. Couldn't have been done without all of your help and support, and please do send them your thanks. A lot of effort has gone in to all of this, and it is quite right that they are recognised. I also wanted to again thank the Charnwood Forest Geopark for the support that they've given, and just to say that we are working with ProGeo, the International Association for the Conservation of Geological Heritage, in the hope that we can all bring you in person to Charnwood Forest, aspiring UNESCO Global Geopark, for the next international symposium on the conservation of geological heritage. More information will go out about that, hopefully in the next few weeks. And about information going out, we will be in touch via email to all you delegates over the next few weeks, hopefully within the next month, just to update you. Thank you for your attendance, and also to give you the updated links to the recordings, because the recordings of the talks will be made available for those talks that we've been given permission to share, and those will be all available on the OxGVC YouTube channel. And then finally, as it was the outcome of our meeting 2 years ago, it is worth reiterating, because it was because of you that this happened, that UNESCO has declared an International Geodiversity Day for October the 6th, and it will happen every single year on October the 6th. So this year it will be on a Thursday, and we are looking to people from all around the world to host events, be that a public lecture, a field trip for local school children, a talk at a school. You could clear up a local geosite that's become overgrown. You could organize a huge, massive national or international event. Big or small, we will only truly celebrate International Geodiversity Day if we engage the public and policymakers with this concept. This is the one day a year when everyone should be focusing on this important and overlooked topic, and we need you to make that happen. So please, please, please go on to geodiversityday.org, where you can find more information about why geodiversity is so important and some of the ways that we might be able to celebrate it on IGD 2022, Thursday, October the 6th. And importantly, there is a registration form on there. Not that you need to officially get approval for your event. It's up to you to decide what you do on the day, but we would love to share your events with the rest of the world to show that there is true international support behind this. So please do go on the website, geodiversityday.org, and share what you're going to be doing on October the 6th, or the few days around it this year, to celebrate geodiversity. Thank you once more to everyone who's joined us today and the 3 previous days. I hope you had a really very enjoyable conference, and I really, really hope that I will get to meet you all in person very soon. Have a great rest of the week, and hopefully see you soon.